The James Webb Space Telescope, locked on a silent, distant region between Mars and Jupiter, records a flicker that shouldn't exist, a sliver of light bending where there should be nothing. Not a planet, not a star, not even debris. Then the signal stabilizes, a faint pulse, repeating, precise, deliberate. For 41 minutes, Webb's infrared sensors track an object no one expected to see again. 3I Atlas, the third confirmed interstellar traveler ever recorded. It had vanished behind the sun months ago, but now it's back. And this time, it's changed. Its brightness, 412% higher than before. Its rotation, slowed by 9%, but unnervingly uniform. And its reflected light, no longer chaotic, but modulated, like a surface responding to heat or commands. What Webb captures next stops every analyst cold. Beneath the glare, the light curve forms perfect symmetry, hexagonal segmentation, aligning in concentric grids across the object's surface. No natural comet has ever displayed such geometry. Then, a flash. 247 seconds apart. Ultraviolet, clean, regular. The kind of timing no comet should ever keep. If this is a comet, why does it pulse like a transmission? If it's an object, why does it behave like a system? And if 3I Atlas truly crossed from another star, why did it come back brighter, colder, and quieter than before? In astronomy, brightness means change. Something shifts, melts, erupts, or breaks apart. But this was different. Webb wasn't watching a breakup. It was watching a response. And deep in the infrared channels, buried beneath solar interference, one line of data appeared that no one could explain. A faint thermal echo, returning Webb's own signal back at it, almost like an answer. To understand what the James Webb Telescope saw, we have to rewind 14 months before the anomaly, back when 3I Atlas was first detected streaking through the outer solar system. It wasn't supposed to exist. Only 2 other interstellar visitors had ever crossed into our domain before it. Oumuamua in 2017, and 2I Borisov in 2019. Both sparked controversy, but both behaved, more or less, like comets. 3I Atlas didn't. First spotted by the Asteroid Terrestrial Impact Last Alert System, ATLAS, it entered from the direction of the constellation Lynx, moving fast enough to escape the sun's gravity. That alone marked it as interstellar. But its light pattern made it famous. In early scans, its glow fluctuated too smoothly for a tumbling rock, yet too erratically for an artificial satellite. The object wasn't just rotating, it was adjusting. Within weeks, ground telescopes in Hawaii, Chile, and Spain joined space-based observatories in a global watch. Hubble confirmed intermittent outgassing, but not where models predicted. Keck Observatory picked up reflected light spikes inconsistent with comet dust. Webb, at the L2 point, recorded subtle infrared harmonics, temperature modulations occurring on a fixed rhythm. The community labeled it peculiar but natural. Yet behind closed channels, researchers whispered another question. Was this thing steering itself? Because every time the object passed near solar wind fronts, its trajectory corrected, as if maintaining balance against invisible pressure. During its approach, 3I Atlas's brightness doubled, then tripled, suggesting either massive sublimation or something we'd never modeled before. An active surface, reflective, adaptive, mechanical. By the time it disappeared behind the sun, telescopes were primed for its re-emergence. But none expected what was coming. When light from the object finally pierced the solar glare, Webb's sensors recorded that impossible 400% surge. Across all wavelengths, the signal pulsed, not chaotically, but algorithmically, as if the object knew it was being watched. That was the moment orientation became obsession. Every instrument turned toward a single mystery, one that seemed to orbit intelligence, not coincidence. To decode what the James Webb Telescope was seeing, scientists turned to the data, heat signatures, light curves, and resonance patterns. What they found didn't behave like rock, ice, or dust. It behaved like a system. The surface wasn't random. It was responding, adjusting its albedo, or reflectivity, to incoming radiation in real time. This wasn't sublimation, it was modulation. Each peak aligned perfectly with Shen shifts in solar flux, as if a sensor network beneath the surface was actively regulating energy flow. When Webb mapped the infrared scatter, it revealed a hexagonal lattice, segments that reflected light in patterns of uniform geometry. Each hexagon altered brightness by minute increments, creating the illusion of pulse waves rippling across the comet's face. In other words, the object wasn't glowing. It was signaling. Even more unsettling was its thermal equilibrium. Normal comets heat dramatically as they near the sun, then cool as they drift outward. But 3I Atlas stayed steady, around 233 Kelvin, no matter its position. To stay that consistent, something would need to manage heat. A natural nucleus can't do that. A designed one could. When the spectrograph readings came through, a new anomaly appeared. Metallic reflectance inconsistent with silicate dust. The signal carried spectral lines of nickel-iron alloy, highly pure, like machined metal, not cosmic slag. Astronomers debated contamination. Could stray satellite debris have interfered? Could cosmic rays have altered readings? But when Webb's backup instruments confirmed identical peaks, the answer seemed clear. Whatever 3I Atlas was, it wasn't made of the same material as natural comets. And then came the strangest discovery of all. Webb's magnetometer detected subtle oscillations, tiny magnetic pulses echoing through the object, repeating every 247 seconds. The same interval as the ultraviolet flashes, infrared heat, visible light, magnetic field, all ticking in sync, not random, not chaotic, coordinated. It was as if 3I Atlas was operating from a central command, something internal, hidden beneath that hexagonal skin, something maintaining balance, symmetry, and signal. If nature built this, it broke its own rules to do it. If something else built it, what purpose would it serve drifting across interstellar space? A thermal regulator? A probe? A remnant of technology older than our sun? No one knew. But whatever it was still working. Behind the data, behind the theories, there were people, tired, blinking, living on caffeine and adrenaline, staring into the eyes of the universe through the James Webb Space Telescope. And on this night, the universe stared back. For the operations team, it began as a flicker, a faint ultraviolet pulse that matched Webb's calibration timing perfectly. Coincidence, they thought. An instrument echo. But when the telescope's orientation shifted by several degrees, the pulse followed. Every reading, every parameter matched. It was as though 3I Atlas had turned its reflective surface toward Webb's sensors and listened. One technician described the moment like watching the universe blink. Another whispered, "It's responding." Then came the second anomaly. As Webb sent its routine calibration ping, a low-power infrared pulse to test mirror alignment, the object's brightness spiked precisely 1.2 seconds later. The team watched in real time as a cold body, millions of kilometers away, seemed to answer back. No one spoke. For nearly 5 minutes, all they could do was watch the data scroll across the monitors, heartbeat-like, impossibly regular. When the first voice finally broke the silence, it wasn't calm. "It's talking to us." Across the globe, observatories scrambled to confirm the signal. Madrid, Hawaii, Maryland, Chile. Within hours, telescopes on every continent were locked onto a single point of light in deep space, a light that seemed aware of their gaze. Each calibration ping met the same result, a mirrored pulse, delayed but exact. No natural object had ever displayed that kind of photometric correlation. It wasn't random, it wasn't noise, it was reciprocity. The logs from that session remain partially classified, but one note survived the blackout, a final line typed before Webb's automated safety mode triggered. Signal reflects with intelligence, continuing capture until confirmation. Moments later, every display in the observatory went dark. A telemetry spike had overloaded the optical sensors. Webb had entered safe mode automatically. something that only happens when the telescope detects potentially harmful incoming energy. The entire feed cut to static. Whatever triggered the overload wasn't random. The final signal mirrored Webb's diagnostic pulse exactly. Amplitude, duration, interval, as if the object had learned the rhythm and sent it back. For years, humanity has dreamed of a response, a transmission, a sign we're not alone. But no one imagined that the first reply wouldn't come through radio waves, but as light reflected deliberately back at us. By the time the Webb data reached public channels, the mystery of 3I Atlas had fractured the scientific world. Every lab, every observatory, every independent researcher had a theory, and none of them fit perfectly. Theory 1. The shattered core hypothesis. This camp argued that 3I Atlas was the remnant of a larger interstellar object, one that fractured eons ago under gravitational stress. The smooth pulses of light? Reflections from perfectly fractured crystalline planes. The hexagonal geometry? Coincidental symmetry formed by high-pressure molecular bonding during ejection from its parent star system. But the problem is timing. Those reflections didn't scatter like fractured ice or rock. They rotated in sync with its orbital position, tracking the sun like adaptive panels. Fractures don't coordinate. They don't self-correct. Something else was at play. Theory 2. The mirror core model. A more radical idea, 3I Atlas as the surviving shard of a Dyson-like construct. If civilizations build vast solar collectors around their stars, fragments might drift between systems. The uniform nickel-iron ratios and near-perfect thermal regulation could support this. The hexagonal structures, remnants of a collapsed energy array. Still, skeptics argued scale. A Dyson fragment that small shouldn't maintain functionality. And yet, the spectral readings showed it still absorbing and redirecting energy as though operational. Theory 3. The autonomous probe. Unspoken at first, whispered later, an engineered vessel designed to travel between stars. A probe that regulates itself against stellar radiation, powered by light, pulsing in mathematically precise intervals. The repeating 247-second rhythm might not be natural resonance. It could be a handshake sequence, the cosmic equivalent of saying, "I'm here." But then comes the counter-argument. Where's the propulsion? No jets, no ejections, no thrust, until the Spanish observatory caught that thin directional plume. A straight beam that maintained heading through rotation. Not venting, not chaotic, controlled. If that plume was natural, it's a cometary outgassing unlike any other. If it wasn't, it's evidence of deliberate movement. There's also a fourth hypothesis, one too speculative to publish. That 3I Atlas wasn't passing through at all, but waiting. The repeated light intervals, the stable energy patterns, the unchanging temperature, all consistent with standby systems conserving power until triggered. Triggered by what? By observation. By being seen. The moment Webb's gaze locked on it, the pulses began. And once the data stream stabilized, every anomaly intensified, almost as if it responded to attention. 3 possibilities, 4 if you count the unspoken, a natural crystal, a Dyson relic, a probe, or something waiting for us to look. None can be proven, all remain possible. But one fact refuses to go away. 3I Atlas hasn't decayed, it hasn't dimmed, it hasn't drifted off course. It continues to pulse, in light, in magnetism, in heat, like a machine that knows exactly what it's doing. Just when the debate around 3I Atlas reached a breaking point, a new dataset arrived, one that changed everything. A routine calibration scan meant to rule out interference picked up something buried deep in the background noise. A second waveform, subtle, repeating, offset by precisely 247 seconds, the same timing as the ultraviolet pulses. But this wasn't light. It was infrared phase modulation, a thermal signal that appeared to carry structure. When decoded into frequency intervals, the modulation revealed a repeating spiral pattern, an echo of the ultraviolet sequence Webb had recorded months earlier. Only this time, the signal was richer, more complex. And hidden inside that spiral, a variation. A single data anomaly that didn't match any known stellar noise or instrument error. A cluster of values that, when plotted spatially, formed a map. The coordinates didn't point to a random sector. They aligned perfectly with the trajectory that 3I Atlas had been following, projected outward beyond Neptune. The map appeared to extend that path toward a region of interstellar space associated with a faint, ancient radio source cataloged decades ago but never explained. It wasn't just a transmission, it was directions. Researchers triple-checked the calibration logs, the angle of Webb's mirrors, the cosmic background models, every variable that could produce false data. Nothing explained it. The spiral and its coordinate markers were there, encoded in thermal pulses, repeating over and over for 8 continuous hours. Across Europe and the Americas, radio telescopes redirected their arrays to the coordinates embedded in the pattern. For 36 hours, they listened. At first, silence. Then, a faint oscillation began to rise. Not random cosmic background, not Earth interference. A distinct rhythm, matching the same 247-second interval. It wasn't loud, it wasn't even constant, but it was there. A pulse repeating from a region millions of kilometers beyond the solar boundary. The implication hit everyone at once. The light pulse, the magnetic echo, the thermal spiral, all aligned to one signature, one system, communicating across wavelengths, across space, across silence. Whatever 3I Atlas is, it didn't just emit energy. It linked itself to a chain of signals already waiting beyond our reach. This wasn't an isolated event. It was part of a network. For nearly 48 hours, the signals ceased. No pulses, no thermal echoes, no magnetometer shifts. Webb's sensors stared into absolute quiet, an emptiness so complete it felt intentional. At first, analysts thought the object had simply moved too far, its signal drowned in cosmic noise. But the readings didn't drop. They paused. Every spectrum went flat at once, as if the system itself had powered down, waiting. Then, just as the silence reached its longest stretch, precisely 24 hours and 42 minutes, a single spike appeared. One pulse, strong, sharp, perfectly timed. Its frequency was unlike any of the previous 247-second intervals. This wasn't a continuation. It was a reboot. The signal contained a high-energy burst in the infrared spectrum, followed by a cascading drop through ultraviolet channels, as if something massive had reoriented in space. For a brief 13-minute window, telescopes from 3 continents picked up scattered reflections that didn't match 3I Atlas' prior trajectory. Its path had shifted, slightly, but unmistakably, toward the direction encoded in its own thermal map. It wasn't just pointing anymore, it was moving. Target shift confirmed. It's aligning with the outbound vector. No visible thrust. How is it accelerating? The acceleration was minimal, measured in fractions of meters per second, but too deliberate to be chance. And as its brightness began to stabilize once more, the temperature readings held steady at exactly the same thermal equilibrium Webb had logged months earlier. That was the moment realization turned into dread. 3I Atlas wasn't finished. It was preparing for something. The silence hadn't been an ending. It was an activation window. No one could tell what would come next. Only that the silence had been broken, and the object was no longer where it had been. Somewhere, beyond Neptune's edge, it had begun to accelerate, aiming toward a place we hadn't yet dared to name. Every discovery raises new questions. But this changed the foundation of what we call natural law. The Webb Telescope had recorded an interstellar object that not only survived the sun's heat, but appeared to answer it. It reflected light with purpose. It regulated its temperature like a living machine. And now, it had pointed somewhere. 3 signals, 3 confirmations, 3 invitations to look deeper. The light, the magnetism, the thermal map. All locked to a constant rhythm, 247 seconds, as if it were a cosmic heartbeat, or a countdown. If 3I Atlas was part of a network, then the coordinates it sent may not be random. Some models show its final trajectory leading toward the Oort cloud, an icy halo marking the edge of our solar system. But when the European arrays rescanned that region, they found something new. A faint reflection, dim, small, steady, not moving with known objects, not cataloged in any database. It blinked once, then disappeared. Was it another fragment? Another beacon? Or was it a response? If this is contact, it didn't arrive as a voice or a message. It came as presence. A silent pattern written in light and distance. A test to see if we're watching. And we are. Every telescope that caught a glimpse of 3I Atlas now waits. Every deep space array is turned outward, listening for the next pulse. The rhythm that once came from a single object may now echo across the void. If this was a probe, it wasn't built to talk. It was built to see, to observe who looks back, and maybe to decide what happens next. What if the universe has been watching us all along, and now, for the first time, it knows we're watching back? The universe has always spoken in silence, through gravity, radiation, light, and time. But for the first time, that silence blinked. A rhythm, a pulse, a mirror in the dark. 3I Atlas came and went like a whisper, but it left behind more than data. It left a question humanity wasn't ready to ask. Not, are we alone? But, are we being studied? Each reading, each reflection, each carefully timed signal adds another piece to the same impossible puzzle. If this was contact, it didn't come in language. It came as observation. A gaze across light years, patient, methodical, curious. Maybe we were never meant to hear a voice. Maybe we were meant to notice a pattern and recognize it for what it is. And somewhere, out beyond the reach of our telescopes, something may be watching the watchers, listening to the echoes of its own reflection. The James Webb didn't just reveal the universe's secrets, it may have awakened one.